Hello students. So I just want to really quickly in this video explain a few different concepts about gears. So first and foremost, let's talk about one of the most basic aspects of gears. When we have two gears that are meshed like this, we call these spur gears. If one gear is spinning clockwise, then the other gear that's attached to it is going to be spinning the opposite direction or counterclockwise, and vice versa. So two gears that are touching side by side are always going to spin in opposite directions. Again, if this one's going clockwise, this one's going to be going counterclockwise, etc. This is important to know. If you are building something in the shop, let's say you've got a motor attached to this gear, you just need to be aware that if you only have one other gear attached, it's going to be spinning the opposite direction from the way the motor is spinning it. So meshed gears spin in opposite directions. Now, let's say we need to get our gears to spin the same direction. What we can do is actually throw in an extra gear in the middle. Let's set these where I can do that. And that extra gear is called an idler gear. So now what happens is, let's say we've got our first one going clockwise, then our idler gear is going to be going the opposite direction, counterclockwise, which will then make our final gear go clockwise. So that makes these two gears on the ends rotate the same direction, which you can see here as I spin this one. So adding an idler helps to have these two gears be going the same direction. Okay, a couple important terms that you need to know. Anytime we're talking about a gear train, the first gear in the gear train, the one that the motor is attached to, is called the drive gear. And then the gear that's at the end of the gear train is called the driven gear. Another term for these would be the input and the output. And then again, the little gear in the middle, if there is one, would be called an idler. All right, so one of our main objectives with gear trains, and one of the reasons why we would have a gear train in a mechanical system, is to try to either increase the speed that's coming out of the engine or to increase the torque. So, what are speed and torque is the question. Well, let's reset this up here. Well, speed, most students are familiar with that term. Most motors are only capable of a certain range of power or torque and speed. So this has a limited input that it can put out. It can only spin so fast and it can only spin with so much power. If we need more power than this motor can provide, or if we need more speed than the motor can output, we can actually set up a gear train to effectively get more power or more speed. But the trick is that speed and power or torque are inversely related to each other. So they're always balancing each other out, and they're in opposition. What that means is if we want to increase the speed in our system, then we're going to end up decreasing our torque or our power. And if we want to increase our power, then we're going to end up decreasing our speed. So let's say, we'll do an extreme example so it's easier to see. So let's say we have our motor attached to this teeny little guy. And this guy has 12 teeth on it. And then we want to connect that over to our biggest gear that we have in our VEX kit, which is an 84 tooth gear. Okay. I'm going to put a spacer underneath this as well. Sorry, one moment. Okay. So our motor is attached to the little guy, and then the little guy is spinning towards the big guy. So every time that the motor spins this around one time, this big gear is spinning much less than once. In fact, if you look at the ratio, we've got 12 teeth on this gear, and we've got 84 teeth on this gear. 12 times 7 is 84. So if you count it up, we're gonna have to rotate this shaft 7 times before the big one goes around once. So let's count it. There's 1, 2, 3, 4, 5, 6, 7, and then there they come together again. So in this situation, you can see that this output shaft is spinning much slower than the input shaft, but this output shaft is going to have a greater torque or rotational power than the input shaft does. So this type of setup with the motor attached to the small gear is going to be really ideal for something that doesn't need to go quickly, can go slowly, but that needs to be able to have a lot of power. Now, what's interesting is we can actually flip this around. If we put the motor on the big gear and have this be the input gear and have the output gear be the little one, then you can imagine the exact opposite is going to happen. Every time the big gear goes around once, the little gear is going to be flying 7 times around. And you can see, if you just pay attention to the speed the shafts are rotating, the little silver things in the middle, this big shaft is moving pretty small while this little shaft is rotating very quickly. And again, if I rotate this big one around once, the little one's gone around 7 times. So this would be what we call a speed build. It's going to have less torque, less power, but it is going to have a lot more speed, move a lot more quickly. There's a way that we can convey gear ratios in numbers, and it does involve math, which I know most of us love so much. But it's really pretty simple. To calculate a gear ratio, there's a few ways to do it. The easiest way to do it with these VEX gears is to simply count the number of teeth and compare the number of teeth from one gear to the other. All of the gears in my shop are labeled, so we don't actually have to count the teeth. We just can kind of look at the label and figure it out. So this big gear has got 84 teeth. The little gear's got 12. And the way that we figure this out is basically we create a fraction. So we're going to put the number of teeth of the output over the number of teeth of the input. And that fraction is going to give us our gear ratio. So in this case, the input gear is always the one attached to the motor, right? So input is going to be the big gear. Output is going to be the little gear, so we want output over input. If 12 is the output gear, then we're going to do 12 over 84. And that is going to simplify down to 1 over 7. So this gear ratio would be a 1:7 gear ratio. That's how we would write it, 1:7. Okay, so you can see the opposite would happen if we moved it again back over to this little gear. Our input and output switch, so instead we'd end up with 84 over 12, which would be a 7:1 gear ratio. In general, looking at fractions, when they're gear ratios, the smaller the fraction, the more speed, and then the bigger the fraction, the more power. So 7:1, that's torque or power build. And then 1:7, that's speed. So depending on what you need to accomplish with your different projects in the shop, those of you that are here in person working with the VEX parts, you might decide to set up your gear trains to optimize for power or for torque, or maybe you want to have more of a balance and keep things a little more even. Last thing that I want to discuss is just a simple concept that your worksheet is going to talk to you about. There's 4 different kinds of movement. that we're going to be talking about in this class. Everything that I just demonstrated is rotary. So rotary is what you would imagine. It's when you have force that goes around in a circle. So that's going to be any of our gears. As our gears spin, that's a rotary force. And rotary is the most common type of movement. It's what most engines are going to put out. So this motor is going to put out a rotary force. Car engines do the same. That rotary force that's coming through an engine then needs to be converted generally into some other type, depending on the application. Sometimes it will remain rotary, and sometimes it will change. So rotary is a circular motion. The next type is linear. Linear is motion that goes in a straight line. And then there's reciprocating. Reciprocating is motion that goes back and forth in a straight line. Now, the difference between reciprocating and linear, they're both a straight line, but reciprocating basically, reciprocating is going to go back and forth over and over and over again, where linear is going to go just in one direction endlessly. And then the last type is oscillating. And in my experience, this is the rarest kind of motion. We don't see it very often, and that's back and forth in a curve instead of in a straight line. All right, those are the basics. If you guys will combine this video with the document that I've attached on Canvas, Observing Mechanisms, should give you a pretty good idea of what's going on, and feel free to research on YouTube VEX gears or types of mechanisms, gear ratios. For more information. I've found a lot of good videos on there that could be really helpful.